overview. So classifying triangles by side length and determine if a triangle is possible. This is day 1 of chapter 8. This is the pre-chapter 8 set that we're doing from here until Friday. So Roman numeral 1, before you can classify a triangle by side lengths, you have to know if you can even make a triangle. So Roman numeral 1 is determine if a triangle is possible. And that was something that on the quiz we forgot to do. We forgot to check that a triangle was even possible with the sides that we were given. Okay, so underneath of that, I want you to draw, skip about an inch, and then I want you to draw 3 segments. Okay, so there are 3 possible scenarios when it comes to the side lengths of a triangle. In the first case, we're going to call, by the way, the bottom side C for all of these, which is the longest side of the triangle. So in the first case, the A and the B are really short. In fact, they are so short that if you try to make a triangle, they fall flat and never actually touch each other because they're not long enough. You can get some paper out. So in this case, A plus B was less than C. The 2 of them were smaller than C. So no triangle is possible. Okay, so let's do another one. This time, make A and B a little longer. All right, so this time A and B are slightly bigger, but when you try to make a triangle, they fall flat, but they're actually touching each other. They're just not making a triangle. So they do fall flat. They're laying against C, just touching each other. That is if A plus B equals C. So if those 2 sides add up to the big side, they might be equal length, but they can't make a triangle. They're still not long enough. So that is, again, no triangle is possible. So the trick to making a triangle, A and B have to be big enough that when they hinge together, they make a tent. They're so long that they touch above the C. So A and B have to be long enough that they actually do meet up above side C. So in this case, A plus B is greater than C. That's the only situation where, yes, a triangle is possible. Yeah.
So how can you tell if it's an obtuse or an acute or just this?
This, first you have to prove a triangle is possible and then you classify it. So we haven't gotten to the classifying part. Okay, so let's do an example. Example 1. Let's say you've got side lengths 3, 4, and 5. C is always the biggest. So your C is 5. And then A and B don't matter. You can do either one, A or B. So your strategy for figuring out if a triangle is possible is you're going to add the smallest 2 sides. So I'm going to take the smallest 2 sides are 3 and 4. So I'm going to go 3 plus 4. I'm going to add them together. That equals 7. Once you've added the 2 smallest sides, now you want to compare that sum to the longest side. So in this case, our C is the longest side, and 7 is greater than 5. So because their sum is greater than their longest side, C, a triangle is possible. So you add the smallest two sides and then compare that sum to the third side. If that sum is bigger than the third side, you have a triangle. All right, let's do another one. Got side lengths 1, 4, and 2. Again, the longest side is always the C, no matter what order they tell you. So C is 4, and then A and B are interchangeable. So we're going to find the sum of the smallest two sides. So I'm going to take 1 plus 2. I get a 3. And then now I'm going to compare that to the longest side, which was 4. Well, 3 is less than 4, which means A and B are too short to meet up and make the triangle. So in this case, no triangle is possible. Okay, one more of these and then we're going to move on. In your assignment, sometimes they're going to give you a radical to work with. So they might give you square root 5 and then a 3 and a 2. So this is something that we practiced doing, which was estimating radicals. So just to remind you how to do that. The perfect square lower than a radical 5 is a radical 4 because the square root of 4 is 2. The perfect square bigger than a 5 is radical 9. And we know that that's 3. So radical 5 has to be between 2 and 3, closer probably to the 2. So maybe about 2.2. So this makes the longest side 3. So that's our C value. And then our A and B are radical 5 and 2. Okay, so we're going to take the shortest two sides and add them together. So I'm going to use my approximated value. 2.2 plus 2 equals 4.2. And then I'm going to compare that to the third side, which is 3. 4.2 is greater than 3. So the sum of the short sides is greater than the third. So yes, a triangle is possible. So this is an appropriate time to use your estimation of radicals. It makes the whole process go faster. Okay, so now we've decided if there's even a triangle possible. So we're going to go on and figure out what type of triangle it is. If no triangle is possible, you're done. Don't classify it because it didn't make a triangle. Does that make sense? A lot of people did that on the test. They said, oh, no triangle is possible. And then they're like, it's obtuse. And I'm like, that doesn't work. Okay, so Roman number 2. Classify a triangle by side lengths. Okay, so there's the 3 basic triangle types classified by side length. There's other classifications, by the way, based off of angles and other stuff. But these are just by side lengths. So we're going to draw 3 of them. We're going to draw a right triangle, an obtuse triangle, and an acute triangle. So a right triangle has a right angle. An obtuse triangle has a really, really wide angle. And an acute triangle is actually sort of what we think of when we think of a generic triangle. Most people automatically draw an acute triangle. Just think cute little angles make it an acute triangle. So those are your 3 basic types, right? Obtuse and acute. Okay, so like before, C is always the longest side. So in the case of a right triangle, that's opposite the 90. And A and B are interchangeable. On an obtuse triangle, the biggest side is opposite the biggest angle. That will be our C. And A and B are interchangeable. And for an acute triangle, you have to know the measurements of the angles. Otherwise, you won't know what the C is. So we're going to assume that this angle is the largest, and that would mean that C is opposite that angle. And again, A and B are interchangeable. Okay, so the test for classifying a triangle is based off of Pythagorean theorem. Pythagorean theorem is for a right triangle that says a squared plus b squared equals c squared. So the other two rules are based off of that. In the case of an obtuse triangle, a squared plus b squared is less than c squared because c is so much bigger than a and b due to the fact it's opposite a really large angle. In an acute, a squared plus b squared is greater than c squared because c is not all that much bigger than a and b. All right, let's do an example. Let's say you've got side lengths 2, 10, and 11, and you're supposed to classify the triangle. So the first thing you need to do, though, is make sure that you even can get a triangle before you try to classify it. So you take the smallest two sides, which would be 2 and 10, add them together. So 2 plus 10 equals 12, and then compare it to the longest side, which is your C value. In this case, it's 11. 12 is greater than 11, so a triangle is possible and we can proceed. Now I'm going to go ahead and call the 2A and the 10B. The main thing is that the largest side is C. Okay, so to test what type of triangle it is, you want to know a squared plus b squared, and you want to ask yourself, what's that relationship with c squared? And that relationship is what tells you the type of triangle. So let's fill the sides in. 2 squared plus 10 squared, and then c is 11 squared. So 4 plus 100 is 104. 11 times 11 is 121. 121 is bigger than 104, which means it has a really long C, which is opposite a really big angle. So this has to be an obtuse triangle. All right, let's do another example. 13, 5, and 7. We're going to classify the triangle. And again, the biggest side, the 13, is the C. And we can just do A and B for 5 and 7. So first thing you're going to do is make sure that a triangle is actually possible. So take the smallest two sides and add them together. 5 plus 7 equals 12. And then you're going to compare that to the biggest side, which is 13. And 12 is less than 13. The sum is less than 13, which means those two sides will fall flat. They won't meet up. They won't make a triangle. So in this case, a triangle is not possible, so we cannot classify it. And you're done with the problem. All right, last one. Example 3. Let's say you've got side lengths 20, 13, and 4 radical 35. And 4 radical 35 turns out to be about 23.7. So you're supposed to, again, classify the triangle. So obviously 23.7 is the biggest side. So that's going to be your C. And then 20 and 13 are A and B. So first thing you do, make sure triangle is actually possible. Add together the two smallest sides. So 20 plus 13 is 33. And then you're going to compare that to the biggest side, which is about 23.7. Well, 33 is bigger than 23.7, so the sum is bigger than the long side, which means a triangle is possible. All right, so now that we know we can get a triangle, we're ready to classify. So again, we're going to do a squared plus b squared and figure out what is its relationship with c squared. So here we go. We have 20 squared plus 13 squared, and we want to know what's that relationship with 4 radical 35 squared. All right, 20 times 20 is 400. 13 times 13 is 169. 400 plus 169 is 569. Okay, for 4 radical 35, we're squaring it, right? So 4 radical 35 times 4 radical 35. 4 times 4 is 16 on the outside. Inside, we get 35 times 35. 2 35s, 1 comes out, and it gets multiplied by 16. Oop, that should be a 35. So 16 times 35, which ends up being 560. So 560 is less than 569. So this is an acute triangle.